All right, we're ready for this word problem here, number 17. And number 18 is going to be very similar. Number 17 asks us to write an exponential growth function that represents the population t years after 2000. And then from there, they want to know what will the population be in the year 2020. All right, if we go to the very beginning of the directions, we will see here that they've given us some interesting items that we can use. 2% annually will be the population increase. And they're telling us this sign for Brookfield is the year 2000. All right, let's take a look. We know this equation from our last few problems with the growth model. Okay, let's plug in what we know. We know our initial amount is 315,000 times 1 plus 0.02 to the t. Again, let's clean that up. We have 315,000 times 1.02 to the t. Now we know that, we can use that in part B, finding out what the population will be in the year 2020. Notice that it says round to the nearest 1,000. No problem. Let's take a look. Using our equation that we just generated in part A, we're going to use a value of t being 20, okay? And again, we're going to use our calculator. We're very good at this part, all right? We're going to put in 1.02 to the 20, and now multiply that by 315,000, and there we have our answer. Let's write that down. Keep in mind that when we did this problem, they want us to round to the nearest 1,000. Okay, this is what we have. To the nearest 1,000, this is what we're going to end up with. Okay, questions. Actually, we need to make it to the nearest 1,000, so that's going to be 468,000. Okay. Why didn't we round up to 4689? There aren't enough people here to make that close to 1,000. This is barely coming into 100. All right, that's why we left it as 468,000. All right, let's move on to a problem like number 19 through 26. These problems look a little frightening, but aren't. Now we're going to do the decay version of problems like we did in 13 through 16. 19 and 20 look pretty comfortable. We can easily tell what the rate of decay is for R. Okay? We could also figure out what the value is for T. I'm going to skip those. I know you can do those. Let's look at something like number 21. If we can do number 21, we can do the others. All right, let's take a look. Number 21, we have G of T is equal to 240 times 0.75 to the T. All right, first of all, we need to know what R is. What goes in this parenthesis would really be 1 minus some number. But whatever it is, it should equal to 0.75. No brainer. I'm pretty sure you can come up with the fact that the question mark is going to be 0.25, right? Excellent. That means that our rate is 0.25. Now we can go on to the next part, which is let's evaluate when t is 3. No problem. So G of t is going to be equal to 240 times 0.75 to the third power. Again, let's kick in our calculator here, clearing it from our last problem. And we're going to put in 0.75 to the third power times 240. That should give us 101.3. Do we need to round it? Let's check those directions. To the nearest tenth. Excellent. We did that automatically. Now, if we're feeling pretty successful here, let's move on to something like number 27. Number 27 asks for us to write a function that represents the situation. Very similar to what we did when we were doing problems 13 through 16. Problem number 27 tells us we have a population of 1,000, decreases by 2% each year. We know from experience, anytime we're talking about decrease, we're talking about this decay function. We know what A is in this case. A is going to be 1,000, our initial amount. And it's going to be 1 minus R. What's R? 2%. 0.02 is what we're going to use to the T. Clean it up a little bit. And we're done. No need to evaluate. Finished. Hopefully this will help you with your homework problems tonight. I'm looking at numbers 31, 32. You need to evaluate and try to figure out whether or not there's a problem. Be careful and make sure that you know your functions. Have those next to you as you look at these problems and try to figure out what each person did wrong.